apologise for people who've seen this presentation before. I gave it in November slightly differently to them, but a lot of it's a bit similar really, so I apologise you haven't seen it before. Right, well in 2012 we finished our own project. When I say we, I'm referring to the three cities of Nottingham, Derby and Leicester. We started back in 2009. The link to the final good practice guide is available on the Nottingham website for people to view. One of the main tasks of the project was to determine an appropriate method of collecting data, which is what I'm going to try and give you some information about today. As touched on slightly earlier, element 2 was some funding that was available from the DFT a few years ago. Our group was quite lucky in that we were able to get some funding to kickstart a project. That money was used obviously to fund the work that we did. The main aim of the project was to share expertise, collect drainage inventory and implement methods of recording maintenance activities, which I think the project's done a good job of doing. We're still in regular contact now. Obviously the project's finished, but it's really fostered some good working relationships. Right, well the four main tasks of the project was to bring records together. Records can be in all manner of things really, but for us it was mainly drainage inventory, cleansing records, hotspot information. When I say hotspots I mean areas known to be prone to flooding. Task 2 was to look at developing methods of prioritisation. Derby City Council did a lot of work here, which really came to fruition in the last year of the project. That was looking around key risks that local authorities can be looking to use to prioritise schemes, things to alleviate potential flood risk. Task 3, data collection methods, which is the presentation today. That was more my close involvement of really, and that was looking at data collection methods, survey equipment, the types of technology out there. And then task 4, which is kind of a summary of all the previous 3 tasks, looking at potential solutions, which the Good Practice Guide hopefully does a good job of promoting. Right, there was quite a lot of research undertaken. Obviously there's a lot of technology out there which is there to help. GPS, of course, there's different varying degrees of GPS out there. We were looking at differential GPS devices. Obviously the advantages of using that type of technology is it's ideal for surveying, get good accurate information, it's suited for mapping and data capture. You can be fairly confident that the information you're collecting is of good quality. Obviously you pay a premium for that, which is what you need to understand early on, what you want to get out of what you're collecting. Standard GPS obviously is ideal for around navigation, but also collecting maintenance records. The trade in there is that you've got it tells you where you are very quickly, but doesn't hold your position very well. It's not really suited towards collecting data in the truest sense, really. Right, on this slide here, there's a diagram. What we try to show here is how the process works for collecting information in the field, which is the differential GPS technology that we implemented. You can see on the diagram that there's 2 elements to it. There's a desktop environment, which is where the projects are configured in the office. On the right-hand side of the diagram, which is the field-based process, which is the surveyor collecting the information. They're very distinct processes, but obviously they come together to form the geodatabase, which is the graphic in the centre there. That information is streamed through 3G back into the office, so there's no need to sync information back in the office. It's all done remotely. That means that the person in the field can collect information without needing to come back to the office regularly. They can work independently, and with relatively quick time frame they're able to get up and going and collect information. And it's not really a requirement to have surveyors in a lot of projects. You just want to have someone who is able to get the process, understand what they need to be collecting, and just get out there and collect the information. This is a graphic of the differential GPS unit. This was selected because it was following all the characteristics that we wanted. It was portable, lightweight, rugged, water dustproof, shockproof, easy for people to operate, utilised drop-down menus, was accurate, used 3G, almost like a phone, just recording information, sending it back through the SIM card, and it was also compatible with our existing systems, which was really, really important. The next few slides show a few graphics from the technology. So this first screen here is what the surveyor would first see. There's just a series of screens from viewing the map to collecting the features, to searching for existing features, and the bottom graphic there is managing edits. That's posting edits back into the office environment. And they're the type of assets that we were collecting, the surface water, so surface drainage assets, carriageway gullies, footway gullies, hollow curbs. It's highly configurable and really easy to configure in the desktop environment and back onto the mobile operator. And these were the attributes that we were collecting, you know, locational information about what was, if the gully was silted up, if it was clear, size, again, very, very customizable. And then this shows a map of, obviously the centre location there is the actual surveyor walking around, and then you've got the point assets there that were collected in the field. And then again, posting the information back to the office is very simple to use. Right. We were very concerned that we weren't just going to use this project to collect inventory, but also to manage data, because obviously the first step in the process is to know what you have, but then it's obviously to keep that up to date, keep it refreshed, attach maintenance information to it, obviously raise inquiries against features. So that was certainly something that we weren't forgetting about when we started looking at devices. So this workflow diagram here just simplistically shows the workflow from inquiry through to the inspection, through to the defect. Obviously the diagram here isn't really related to drainage specifically, but the workflow applies to all different work streams that we undertake in our team. So the mobile working, the operative can essentially record what happened in the workplace, send it back into the office environment, and then verify it for the person in the office. Again, there's no need for paperwork. We used to have quite a complicated system of creating client and contractor copies. The contractor copy was given to the field worker. We retained a client copy, and essentially it was then signed off. Paperwork would get lost. All manner of things could go wrong. So we've got a much firmer grasp of the workflow now. We're able to see what's happening where and when, and to give information back to people as they need it. This next screen shows the tablet devices that we used to do that workflow. Again, it's a rugged device, very hardy, and it's being used by fieldwork operatives, so it needs to be. It's got long battery life, 16 hours battery life in it. Large screen, 6-inch screen. Utilises drop-down menus again, so there's no free text, easy to operate. Essential that it uses 3G, so there's no need to do any docking back in the office environment. And again, it's compatible with our existing system, which is, again, crucial when looking at purchasing any technology, really. Once again, just showing some screenshots from the device. The stickman there signifies the person working out there, and then the features there will be gully features. This is some of the asset information that we previously collected and now storing in the office system. Able to record conditions against that, and again that built up a history of known problems to us, and then we can record defect types against them. And again that just shows the outcome of the visit. So then the benefits of mobile working. For us it's removed dependency on paper-based systems and clerical support that we needed before. We're now able to deploy work remotely to people in the field and don't have to collect information from the office. Being one system, it's fully auditable and everyone can see at what stage the work is in processing. It increases our working and reporting performance, monitoring capabilities. It enables colleagues to understand issues more in real time. We think in the long term it will allow the service area to build up a picture of known problem hotspots, again, which is really important for planning purposes. In the longer term, we hope that it will improve response times. We're cutting out a lot of needless stages in the process, so it should quicken knowledge to staff in the office. They'll know what's happening where and when. And finally, this is just a screenshot of the Good Practice Guide, which was published in July. An electronic copy can be found through the web link below. And I'd just like to really depart by saying that I think that we've made a lot of progress from working collaboratively together. We couldn't have dreamed to do as much work alone, and really, although we did have our issues, there were staff departing throughout the project. There wasn't always the continuity there. We were able to get strong management buy-in, which enabled the project to continue and obviously to produce this guide, which hopefully people will find useful. It's predominantly aimed at urban authorities, cities effectively. And more than anything, it just shows that really what can be achieved in a short period of time. So we're quite pleased with how the project finished, and thank you everyone for listening.